Modern Warfare 2, an iconic game. Great guns, fun gameplay, and learning fun new words from fellow gamers. Arguably, the most iconic item from that game is the heartbeat sensor, a device that lets you see exactly where your opponent is hiding. I always thought how cool it would be to have a real one. While perusing YouTube one day, I happened across this beautiful little thing, a 24 GHz radar module, a sensor designed to detect and track human presence. Now, I should be clear, this doesn't detect heartbeats, you'd need some much more sophisticated hardware for that. But tracking presence, close enough for government work, and by government work, I mean airsoft. Hardware-wise, this is a pretty simple build. Radar module, microcontroller, and basic I2C display. This is the LD2450, a 2-axis human presence radar module. This little beauty works by continuously emitting a 24 GHz radio frequency and then using the 2 receiving antennas that are oriented specifically to be able to determine both the X and Y coordinates of targets. It has its own microcontroller on board with firmware specifically to filter the signal to detect only human targets. It can track up to 3 people at a distance of up to 6 meters. A beautiful plug-and-play solution for this project. Basically, impossible to screw up. Next is the Seed Zhao RP2350. This particular microcontroller was chosen because even at this postage stamp size, it has more I/O than I need and also features an integrated battery charge controller. Lastly is the 2.42-inch OLED. This was chosen because the nice blue color that resembles the heartbeat sensor from the game and I2C is easy to work with. My plan was simple, wire it all up, dump the code on, and get back to complaining about my KD ratio. What could possibly go wrong? This is a mess. Oh, that's a disaster. Today we learn how to stab yourself while doing electronics. Oh, you sweet summer child, everything could go wrong. First, the wiring. Should be easy, the radar module communicates over UART. RP2350 has UART on pins 0 and 1. Upload the example code and nothing. Absolutely zilch. Alright, that's fine, we're still testing. The RP2350 has multiple UART interfaces. I tried a different one and still no luck. At this point, I'm questioning my life choices. After some frantic digging, cross-referencing, and perhaps a small existential crisis, I found the culprit. It turns out on the Seed Zhao, pin D0 does not tie to GPIO 0. So, after wiring it to the actual correct pins, we're finally getting data. Success. Now we get the screen connected and write a bit more code to output the data to the display. We are cooking, data streaming, OLED displaying, we've got a heartbeat sensor. Except the distance or y-axis is tracking properly, but the x-axis is just wrong. It doesn't seem to be updating at all when I walk in front of the sensor. Time to do some debugging, and some more debugging, and a bit more writing and rewriting code, analyzing the outputs, and berating and abusing several different AIs for being even more incompetent than myself. 3 hours. I spent 3 hours assuming my beautiful, pristine, genius code was flawed. Then, after a deep dive into the datasheet for the radar sensor, I found it, and yep, the code is fine, the sensor just needed to be rotated by 90 degrees. Anyways, with that problem solved, it's time to stop looking at screens with code and start looking at screens with 3D models. With the case modeled, it's onto 3D printing. This took a few revisions, but I got there in the end. The final design incorporates a hinge and M-lock mount so I can actually attach it to my airsoft rifle. Now for the assembly. This is the easy part, right? Just slap all the parts in and close it up. Shit. Okay. Now the smart thing to do is figure out if it needs to go this way or this way before I glue it in. Are we feeling smart today? Let's stick the battery on. I need to leave room for the lid. Oh, damn it, damn it. Okay, I'll clean it up. We'll fix it in post. Okay, time to test. Oh no, no! Oh, that's a disaster. Today we learn how to stab yourself while doing electronics. Okay, maybe I should have spent more time on the model, but we got there in the end. It looks great, it works great, it's time to start submitting bids for government contracts. Lockheed, L3, call me. Except the screen is clearly displaying data, but the x-axis is mirrored. The sensor is upside down. Are we feeling smart today? No matter, a quick code fix. This time it actually was quick and it's good to go. Behold, a real-life, human-detecting electronic wall hack device. Let's slap it on my airsoft gun and go try it out. Before you go, we will be exhibiting at Open Sauce this year. If you'd like to see this project in person, be sure to stop by and say hi. Thanks for watching and